Hello, my name is Yaman Abraham Gabramadin, and today we'll be talking about a progress report on our project, which is to design an artificial gas lift valve, which would be used as a demonstration at the Perth facility. In our progress, we did two main stages. The first one is we visited a Weatherford facility in Lafayette, Louisiana, and we met with a chief engineer there, and we asked different questions to successfully understand the process and successfully finish our project. In the second part is we took a survey of possible locations for equipment setup and demonstration at the Perth facility. My teammates today will talk briefly about each step we took, and Quang Pham would talk about Weatherford visit in Lafayette. Thank you.
Thanks, Yaman, and my name is Quang Pham. I'll be speaking to you today about our trip and our site visit to Weatherford out in Lafayette, Louisiana. The guys out in Lafayette, Louisiana were so kind to us to give us a site tour, to meet with us, and then to talk about our future design and complications that we're going to address. Chief Engineer Zlatko Begovic was able to sit down with us and talk to us about the different types of designs that he came across whenever he was designing a transparent gas lift valve. He was able to show us the different types of valves and the pressures that he tested his valve that they actually use, and being able to have seen that beforehand gave us a better horizon of understanding the different parameters that we have to address, the different parameters that we have to plan towards. This was able to help us drastically in our project and our planning phases, because now we know what we need and the different types of materials. He was able to show us the manufacturing designs and also the people that it took to build it, and then also a time frame and a timetable. As you can see here, this is Weatherford's design. And it is acrylic at the very top, which is, if you can zoom in or not, you can see that the gas lift valve is actually functioning and is made of an acrylic type material that is able to withstand, I believe, 800 psi. Inside, you can see that there are certain types of bellows, and this is almost like a spring action loaded valve. So when the pressure is built up inside the gas chamber on the bottom through the orifice, it was able to pressurize, and then it releases the pressure into the formation, and then that allows it to travel through the bottom of the mandrels and then going up, and then that starts the process of a artificial gas lift.
Hello, my name is Athanasios Stavropoulos, and today I'm going to be talking about the design aspect of the gas lift valve. When we went to Weatherford last week, we were introduced into some information about both the design and the process simulation of the gas lift valve. We were told that the best way to do it would be to get an acrylic chamber made out of material called polycarbonate, and it would be 2 inches in outside diameter. Also, the orifice is going to be made out of the same material called polycarbonate. Currently, we're in contact with mainline machine ink for the materials for the acrylic chamber and the orifice, and we're also in contact with PVC mechanical seals for the materials for the bellows. For any further information that we might need in the future for our project, we are still in contact with Weatherford, and we are scheduling a meeting in the near future.
Thank you, Nasus. Hi, my name is Leonte Barreto, and we'll talk about the process simulation part of our project. In our process simulation, we will have 3 tubings. One is going to be a 4-inch tubing, which is going to simulate a reservoir. The middle one is going to be a 1-inch tubing, which is going to simulate our production tubing. And the third one will be a 2-inch tubing, which is going to simulate our casing tubing. Casing tubing and our production tubing, we will have a set of valves at different depths. This set of valves will include a gate valve and a check valve, which is going to simulate what the IPO valve does. At the bottom of all three tubings, we will have all of them connected, and this is going to simulate the orifice valve, gasket valve. Now, a little bit about the process. We will pump, first we will use air and water to simulate it. We'll also pump this air using a pump through the casing, and at the same time opening the first set of valves. Once this valve is open, it's going to mix with the water in the production tubing. Once the pressure is low enough, we will close the valve and we will move on to the next set of valves. We will repeat the process all the way down to the bottom wall assembly. Once the pressure in the production tubing becomes low enough, we will be able to drive the water out of the reservoir and through the production tubing to the surface.
All right, this will conclude our video report for our project, and we would like to thank the engineers at Weatherford facility in Lafayette, Louisiana, and the staff at Perth facility. Thank you.